Hello everyone. In today's lecture, we will enable Node 2 to start mining. In the previous lectures, mining permission has been set only for Node 1, but we want other nodes as well to start mining the blocks so that the load can be distributed. For example, if you have, say, 100 nodes or 200 nodes, and you can give the mining permission only to certain limited nodes after signing some private key contract or legal binding contract, this way, you can be safe. Also, since here we are talking about a private blockchain and converting it into a public blockchain, you need to ensure that not everyone can start mining it. The mining should be very difficult and complex. Now the question is, how to enable mining? Undeniably, the mining process is nothing but adding a block by recording transactions into it. Let us assume that there are 100 blocks available right now in the blockchain, and every node is synced together to the 100 blocks. Next step is that one node has to identify the next block by getting the unconfirmed transactions from the network, which are floating, and record them into the block. But the process is not that simple, because you have to identify a nonce, which is nothing but a random string, in such a way that after pushing all the valid transactions into the block, adding the nonce as well as creating the hash of the block, that hash should be less than the hash of the most recent block. In Bitcoin, this is a rigid rule, but in multi-chain it varies depending on the use case and configurations. Next, I will explain how to enable mining. It is a simple process, and all you need to do is enable the permissions for Node 2, and the moment it receives this permission, it will start mining. The first step is to SSH into both nodes 1 and 2, and then make sure you are in the interactive mode on both servers. After that, I will check the permissions in Node 1 to see who has the mining permission. It's clear that only Node 1 has the mining permission. To give permission to Node 2 for mining, execute the command grant space address of node 2 space mine, and it is done. If you check the list of permissions again, and you'll see node 2 now has the permission to mine. We can also get the information and see how many blocks have been mined. You can wait for 15 seconds if there is no new block. Then check the block height again. Here, the available block height displays 357 blocks inside it, which have been mined by the time we started the blockchain. In fact, this information remains the same in every node. So if we try to get information on node 2, it will show the same number. However, as you can see, this number just increased in the small interval between checking these two nodes. Post this, we will check the block details. Use the command getBlock with the block number. For example, if I want to check block 357, and you can see this is the signature of the block, it has every information about the block, hash of the block, who was the miner, which in this case is node 1, as it says IDFG in the address. Let us check block number 358 again, and you will see it has been mined by the same miner. If I check block 359, here you can see that the miner has been changed. Another block we can check is block number 360, which you can see is mined by the previous miner. Next, we can check block number 361, which shows a different miner, and then block number 362 goes back to the first miner. Consequently, as we keep moving ahead, the miners keep changing. This was all about mining, how to enable it, and how to make sure the block is being mined. And now the block's frequency of mining will remain the same, whereas the load will be shared by two servers now. I hope this lecture was helpful for you. In the next one, we will discuss Multi-Chain Explorer in detail. If you have any queries, email us on hello@blockchain-council.org. Thank you.